Hello, I'm Anna Mackay, and this video and topic is called continuous random variables. So think about where we've come from. We've done discrete variables. What's the difference between continuous and discrete? That's something you've probably been doing in statistics for a few years at the lower levels of maths. Discrete data is data that you can count, and continuous data is data that you can measure. The classic ones for continuous are weight, height, and time. So let's have a think about eggs in this example here. You might have an egg, and on one scale it comes up as weighing 63 grams. If you then took it to a different scale that had some decimal places in it, it might actually be 62.9 grams. Is it exactly that, or could that be even more accurate? If you took it to a scale that had two decimal places, it might end up being 62.85, which would round, or 62.94, which again would round to 62.9. So continuous data is something where, depending on your level of accuracy, it could keep being refined. Unlike discrete data is data you can count. Say, for example, the number of eggs in a carton is definitive, so there would be 12. You wouldn't have varying decimal places in this case, and so that's the difference between the two. Just some points to remember: when we graph these in a histogram or a column graph, they don't have gaps between the columns. And let's say here, what are the chances, what's the probability of randomly selecting an egg that weighs between 50 and 55 grams? It would be 6 out of 50. You convert that to a decimal, and that's your relative frequency for that range. You might ask yourself, so when you're looking at this histogram here, an egg between 50 and 55, does it have to include 55? At some point you have to make a cutoff. Now remember, there is no such thing as 55 exactly. And so we can have that range, and if that is the range that you would be after, if you're wondering about the egg that weighs 55 grams, you might ask yourself, do I have to include this next range as well? No, you don't. This is the range that you would be after. If you have a think about that, that'll probably make a bit more sense. Let's do one example here. So we have the speeds of 30 cars travelling past a school are recorded, and the limit in that school zone was 40 kilometres an hour. The first thing we're asked to do is organise the data into intervals of width 5. Now I've constructed that for you, but if you had to do that yourself, you'd look at the data, width of 5. The classic thing to do is counter up on the 0 and the 5, 0, 5. Don't necessarily start at 33 and then add on intervals of 5 after that. That's not neat. So I've done that. Notice that the endpoints, the 45 is the end of that endpoint and the beginning of this one, but it's only equal to on one end if you have to create your own table. So we're doing a tally. So we look at the first one, 33, and that fits into the first row there. So we put a tally of 1. 43 would fit into here. 49 is between 45 and 50, and so on. So I'm going to go ahead and fill in this frequency tally table. And then adding up those tallies, so we have 6, 5, 5, 6, 4, 2, 1, 1. So that's part A. Next, we're asked to draw a histogram to display the data. I've written the frequencies down here. So let's go ahead and do that. Let's put arrows on our axes because they continue. Let's label our axes. So on the vertical we would have frequency, and on the horizontal axis we would have the speed. Thinking about the space, how many columns are we going to have here? 1, 2, 3, 4, 5, 6, 7, 8 columns. Now, where do you start? You're not going to have gaps in between, but in this particular data, this is less than 40. So essentially that's things from 0 up to 40. So we will start at the origin, and we're going to put 40 here. The next one along, we're going to put 45. Now, an apology, the numbers here are wrong. I should have changed those ones. There we go, I've changed them. Now I'm just going to fill in my horizontal axis and filling in my vertical axis as well for frequency up to 6. And now you draw your column graph. Please use a ruler for this. I don't have one at the moment. So the first column is going up to a frequency of 6 and down there. The next column goes up to 5. Finish that off. And the numbers that are after 70 are in that final column there. Perhaps we could have 70 plus for that one there. So now we're going to do some calculations. We have to calculate the relative frequency for each interval. So what is that? That is, how often did each one happen divided by the total number of data. So for our first one, we would do 6 over 30, and that gives us a decimal of 0.2. The next one would be 5 over 30, which gives us a decimal of 0.17. You don't have to write all of the fractions, just filling in the decimals. And what would the total relative frequency be? That's all of the combinations added up. The total should be 1, and a great way to check is sit there and add them up and see if they come to 1, because if you've rounded properly, then it should, and in this case it does. And we are asked to estimate the probability that the next car travelling will be faster than 50 kilometres an hour. So have a look across the data, or you could read it off the histogram, the column graph. So greater than 50. So that is going to be from this column or this row and all of these. Two ways to do this. I'll show you one way here. We could add up 6 cars plus 4 to 1. Out of how many cars in total? 30 in total. And that gives us a decimal of 0.47. And the probability statement for that, which I probably should have written first, is x is greater than 50. Could it be equal to 50? This is something, don't get too caught up on that. Could a car be exactly 50 kilometres an hour? Well, the fact that we're doing continuous variables means no, it couldn't be. So feel free to put equal to 50 then, or not, in terms of the wording of the question, but in terms of which rows that you go and read out of, and again, apologies, these numbers are wrong. I'll fix them up. You do read from this row onwards. You don't have to read from the previous row. And then the last one, let's write a probability statement that we want between 40 and 50. And you might be asking yourself, okay, what letter do I put in the middle? We tend to put an X, and you put between, and you're asking yourself, do I put the equal to or not? Don't be too hung up about this. In terms of the Year 12 exam, you're not going to be penalised for this sort of thing in these beginning questions. We're just trying to get your head around it. Perhaps I'm actually going to take it off that last one. So between 40 and 50, so you can see the two rows that we're interested in here. And this time around, I'm going to add up the relative frequencies. So I'm going to add up 0.17 and 0.17 to give me a total probability of 0.34 for the chance of the next car being between 40 and 50 kilometres an hour. All right, the next one in this series is, there'll be 2 videos, probability density functions. Thank you.